Hello. Integrate this with respect to x. So this is a fraction, and since the numerator's highest power is 4 and the denominator's highest power is 3, it is an improper fraction. And for us to integrate, you have to first change this to a proper fraction. That is by doing long division. So you have x cubed plus x outside, then x power 4 minus x cubed plus x squared plus 1. X power 4 divided by x cubed, you get x. When you multiply this times this, it will give you x power 4. And when I multiply this times that, it will give me x squared. So plus x squared. Then I have to subtract this. X power 4 minus x power 4 gives us a 0. And then x negative x cubed minus, we have nothing here with x cubed, so we shall be left with minus x cubed. And then x squared minus x squared, you get a 0, and 1 minus nothing here with a constant term. It is plus 1. And then we continue dividing. X cubed divided by x cubed, you get 1, but negative because of this. And then multiply this times that to give us negative x cubed, and negative 1 times x, you get negative x. Again we subtract, and this one becomes a 0. Then this one is 1 plus x. So this is what we have as the remainder. So that expression, which was x power 4 minus x cubed plus x squared plus 1 over x cubed plus x, can be written as x minus 1, then plus 1 plus x over x cubed plus x. Now, this is what we are supposed to integrate, but again, when you look at this fraction, it can be expressed as 1 plus x over x into x squared plus 1, which calls for partial fractions. So we're going to first express this to partial fractions before integrate. So 1 plus x over x into x squared plus 1 in partial fraction form will be a over x plus bx plus c over x squared plus 1. Since the denominator is a quadratic expression, then the numerator should be written in linear form. So this gives us 1 plus x to be equivalent to a into x squared plus 1, then plus bx plus c into x, where the denominators cancel. Now, to find the values of this constant, the a, b, and c, we can let certain values of x. For example, when x equaling to 0. So if x is 0, it will eliminate this whole part, and we are left with a into 0 squared plus 1, which is a. This side and this side is 1, so a equals to 1. And after letting that, we can also let x to be any other value, but it will be easier for us to equate terms now. That, for example, if we equate the coefficients of x squared, so this side we don't have an x squared, so its coefficient is 0, equaling to this side coefficient of x squared is a, when I open the bracket, and the coefficient of x squared here is b plus b. So since a is already 1, put it here, our b will become -1. And then we can also equate the coefficients of x. Now the coefficients of x, this side it is 1, equals to, for this first part we don't have any coefficient of x. Then for this we have c, so c is equal to 1. Now, having got the values of a, b, and c, we can substitute back into our expression. And then we integrate. So we have here this part, which is x minus 1 plus this part which we have expressed as partial fractions, a over x plus a, which is 1 over x, and then plus b, which is negative bx, then plus c, which is 1 over x squared plus 1. So this is what we are going to integrate. This single fraction, we've separated it to get these. So we are going to integrate these separately. That the integral of the all of this with respect to x. But again, before integrating, I can first separate this. So the integral of x minus 1 plus 1 over x, then minus x over x squared plus 1, and then plus 1 over x squared plus 1 dx. So the integral of x is x squared over 2, then the integral of 1 is negative x. Then the integral of this one will be ln x. Now the integral of this, I can first manipulate this. The derivative of the denominator is 2x. So if I give a 2 here and I multiply by a half, I'll have got the natural logarithm, that will be minus a half ln of the denominator. Then the integral of this is the tan inverse of x, then plus c. If you're having any troubles in how to integrate all these functions, just visit my channel and see how to integrate some of these. So this is our answer. Thank you.